Oi lads, it's Danny here today, bringing you lot a lovely video. In today's video, I'm going to take a look at how to solve this integral. Right, so the first step that you lot are going to need to ask yourselves is, can you solve this without using a technique from calculus? One of those special techniques? The answer is no, you cannot. You have to use a special technique to solve this. And which technique am I referring to? The U-substitution. And why is that? Because you lot have a bracket, so straight away, as soon as you have a bracket, that's kind of, it's pointing towards a U-sub. But to add insults to injury, you have a to the power of t, which shows up twice. So that basically really points to this being a U substitution. So let's apply a U sub and see how far we get. So if we say that U is equal to a to the power of t, we are then going to take a derivative on both sides of this equation. So the left-hand side is going to be left with du is equal to a to the power of t ln of 8 dt. We are then going to rewrite it in terms of dt, and we are going to take this dt and substitute it back into the integral. So let's rewrite the integral. When it has been rewritten, we are then going to decide to simplify this integral by removing terms that appear in the numerator and denominator. And there's a term that I'm looking at right now which can be eliminated, and that's a to the power of t in the numerator and the denominator. So that's going to cancel out. And notice we have an a to the power of t. And remember what we said, according to the u sub, we have stated that u is equal to a to the power of t. So therefore, this could be replaced as a u. Very important. So we have this integral when it's rewritten. We are going to take the constants and move them outside the integral. And the constant we have here is 1 divided by ln of a. So we are going to move it outside the integral, and it leaves us a very simple and standard integral to solve. It's the integral of sine of u du. And this integral basically is equal to negative cos of u. And let's basically solve it. So don't forget your negative. And you're going to have basically the result of this integral is negative 1 divided by ln of a cos of u plus c. Plus c is plus a constant. So according to integral calculus, you need to add a plus c, plus some constant. Right, the last step is to basically replace a to the power of t as a u variable, because what are we solving for? We are solving in terms of t. We need to replace a to the power of t as the u variable. And that's your answer to this problem. So if you lot enjoyed this video, please drop a like and subscribe, and I'll see you lot later.